Now students, here I took an activity related to your chapter number 6, right? So this activity based on a coin. So here we have total 8 coins here, right? 1, 2, 3, 4, 5, 6, 7, 8. Total 8 coins. Now here we arrange these all 8 coins in a different orders. Sometime one row and 8 columns, and in another sequence also. So now first we arrange these all coins like this. Right. So dear students, you all know that if here we take this horizontal line here, so it means these coins are arranged in a row here, and in this way these are columns here. So what is the total number of rows here? 1, right? And what are the total number of columns? 8. 1, 2, 3, 4, 5, 6, 7, 8. So here we write 1 row and 8 column, and here we get 8 coins total, right? 1 row, 8 columns, right? So here we write 1 multiplied by 8 equal to 8 here, total 8 coins. Now we arrange these all coins in this order, right? So what are the total number of rows here? 1, 2. So here we write 2 multiply by number of columns 1, 2, 3, 4. So here we write 4 here. So here we get 2 4s are 8, right? Total number of coins 8. Now here we again arrange these coins in another order, like what are the total number of rows here? So remember one point here first we write number of rows, and after that we write total number of columns here. So 1, 2, 3, 4. Total number of rows 4. Total number of columns 1, 2, right? 1, 2 column. So here we write 4 2s are 8. Then here we again arrange these all 8 coins in this order, right? In this order. So what we observe here, so here we get only 1 column here and 8 rows. So what are the total number of rows here? 1, 2, 3, 4, 5, 6, 7, 8. Total number of rows 8 here. And what are the total number of column here? 1, right? So we write 1 here. Then 8 ones are 8. Total number of coins 8, right? So now dear students, here we arrange these all 8 coins in a different orders, and what we observe here we get 2 numbers, right? Here we get 2 numbers which we multiply with each other, and here we get the total number of things or coin, right? Here we get total number of coin here. Then 2 4s are 8, 4 2s are 8, and 8 1s are 8. So basically here we get the factors of 8 here. So these are the factors of 8 here. So here we write factors of 8 equal to 1, 2, 4 and 8, right? So here we get the factors of 8 here. So basically here we learn what is factor. You also try this activity in your home. Now friends, today we will start our new chapter, and the name of the chapter is, this is chapter number 6, factors and multiples. Now students, here we will discuss factors, how we find the factors of any number here, and after that we will discuss multiples, right? Now here first we will discuss what is factor basically, and what is the definition of factors. Okay, what is factor? Definition of factors: if a counting number divides another number exactly. If a counting number divides another number exactly without any remainder, then the divisor is a factor of the dividend, right? So here we take some example related to how we find factors. Right. Now here we get first example. Right. Okay. First part A, 19. Okay. So 19 is divisible by 1. So here we write 1 multiplied by 19. So here we have 19 here. Right. Then there is no other number which divide 19 exactly, means without any remainder. So there are two factors of 19 here. Factors of 19 is equal to 1 and 19. Right, 1 and 19 only. Because 1 multiplied by 19, here we get 19 here, and 19 ones are 19. Now here we check the another number, 14. Okay, so 14 divisible by 1, so here we write 1 multiplied by 14. So here we get 14 here. Then here we check by 2. Yes, 14 divisible by 2. So here we write 2. 7s are 14. In a table of 3, no. 14 is not coming in a table of 3. In a table of 4, no. In a table of 5, no. In a table of 7, yes. So 7 2s are 14. In a table of 8, not in a 9, not in a 10, 11, 12, not a 13. In 14, 14 ones are 14. Right. So here we get these 4 factors of 14 here. So here we write factors of 14 is equal to 1, 2, 7 and 14. So these are the factors of 14 here. And here we say that if the number divide this number exactly without any remainder, so it means it is the factor of the given number. Here like 2. To divide this 14 7 times, 2 7s are 14, and here we get no any remainder. So here we say that 2 is a factor of 14 here, with the same as with 7 and 14 and 1 also. From these two examples, here we say that every number has at least two factors, 1 and number itself. Right? So every number has at least two factors, 1 and a number itself. Example like 19. 19 having two factors at least, 1 and a number itself. The second point is all the factors of a number are either less or equal to the number. Right? So the second point is all the factors of a number are either less or equal to the number. Okay? Here we remember this note here. The first point is every number has at least two factors, 1 and number itself. And the second point is all the factors of a number are either less or equal to the number. Okay? So example like these, factors of 14. So factors of 14 are less or equal to the number. Right? 1 to 7 are less as compared to 14, and 14 number itself also the factor of 14. Now here we solve a question related to find the factors of the numbers. So the question is write all the factors of each of the following. Now, here first we find the factor of 15 here. So here first we start from 1. If you multiply 1 and 15, so here we get 15 here, and you also say that 1 divides this 15 times without any remainder. Now 2. 15 is not divisible by 2, right? Now 3. Here 3 divide 15 how many times? 3 5s are 15. Right. Now what about 4? 15 is not divisible by 4. 5? Yes. 5 3s are 15. Now 15 is not divisible by 6, 7, 8, 9, 10. 15 divisible by only 15 here. 15 ones are 15. So here we get total 4 factors of 15 here. So here we write factors of 15 is equal to 1, 3, 5 and 15. 1, 3, 5 and 15. Right. Now here we find the factors of 28. So here first we start from with 1. Here first we start with 1 here. 1 multiplied by 28. Here we get 28 here. Next 2. 28 is divisible by 2. How many times? 14, right? And 14 is the 28 also. So we will get 28. 28 is divisible by 4? Yes. 7 times. 4 7s are 28. Now what about 5? 28 is not divisible by 5. 6? No. 7? Yes. 7 4s are 28. Then 14. 14 2s are 28. Then 28 1s are 28. Now here we get total 1, 2, 3, 4, 5, 6 factors of 28 here. Factors of 28 are 1, 2, 4, 7, 14 and 28. Okay students? So now here we repeat these numbers here like 1, 2, 4 and again by 7 and 4 because 7 and 4 here repeat because you all know that. If we multiply 4 and 7 and 7 and 4 here we get same product here. And if we multiply 2 and 14 and 14 and 2 here we get same product here. Now 1 multiplied by 28 and 28 multiplied by 1 here we get same product here. So here we not in the next question here we not repeat this part of this and here we not repeat the factors of the number here. Take the next number here and the number is 36. Number is 36 here. Now here we will start with 1 here, 1 multiplied by 36. Here we get 36 here as a product. Now after that we divide this 36 by 2. How many times to divide this 36? Yes? Yes. 18. Right? 18. And you all know that 18 cubes are 36 also. Now 3 divide this 26 12 times, and you all know that 12 3s are 36. Now 4 9s are 36. 36 is not divisible by 5, so you can take 6 because 6 is a 36. Okay, so 36 is not divisible by 7, 36 is not divisible by 8 but by 9, and here 9 4 is also 36 and 4 9 is also 36. So here we not repeat these again, these factors again and again here. So here we take factors from this all factors of 36 here. Now here we write factors of 36 is equal to 1 2 3 4 6 1 2. Okay, so here we write 1 2 3 4 6 and 6 after that 9 12 18 and 36. 9 12 18 and 36, right? And you also write factors of 36 like 1 31 comma 36 comma 22 comma 18 comma 3 comma 12 comma 4 comma 9 comma 6. But here we write in proper sequence. So here we write 1 2 3 4 6 9 12 18 36, right? So here we get factors of 36 1 comma 2 comma 3 comma 4 comma 6 comma 9 comma 12 comma 18 and 36. The all factors are less than the given number, mean these all numbers are less than 36. 1 2 3 4 6 9 12 and 18, and also equal to the 36. The factors of the given number less than the given number or equal to the number. Numbers are divided into two parts, prime numbers and composite number. So here first we will discuss about prime and composite number here, right? Write the definition of prime and composite number, and actually here we will discuss what are the prime numbers and why we say these numbers are prime and composite number. What are the prime numbers actually? A prime number is any natural number which has exactly two factors, 1 and the number itself. Okay, so what are the prime numbers? Numbers having two factors only, 1 and the number itself. Now here we take two examples here. The first one is 13, right? Because 13 having only two factors, 1 and 13, right? So here 13 having two factors. Factors of 13 is equal to 1 and 13. Now same as another example, like 7. 1 multiplied with 7, we get 7 here, and 7 minus 7. Factors of 7 is equal to 1 and 7. Prime numbers are the numbers basically which having a natural numbers which having two factors only, like 13 and 7 here. This 13 having only two factors here, 1 and 13, and 7 having only two factors, 1 and 7 here. So if we say that these numbers are prime, right? There are lots of other examples also related to prime numbers like 11 and 17, right? 19, lots of other examples also. Now here we will discuss composite number. What are the composite numbers? Now here we will discuss about composite number. What are the composite number? Composite number, every natural number except one that has more than two different factors is called a composite number. Here we take example here. 8. Okay, so here you find the factors of 8 here, because 8 having more than 2 factors. So 1 multiplied by 8, we get 8 here, then 2, 2 4s are 8, then not divisible by 3, but 4, 4 2s are 8, right? Not divided by 5, 6 and 7, but in 8, right? 8 ones are 8. So here we get these factors of 8 here, 1, 2, 4 and 8. So here we write factors of 8 is equal to 1, 2, 4 and 8. So here we say that factors of 8 are 1, 2, 4 and 8. Now here we take another example like 24. Now here we start from 1 multiplied by 24, here we get 24 here, then 24 divided by 2, 2 multiplied by 12 and here we get 24 here, then 3 8s are 24, then 4 6s are 24, then not divisible by 5. Right, then again 6 4s are 24, 8 3s are 24, 12 2s are 24 and 24 1s are 24. So here we write factors 1, 2, 3, 4, 6, 8, 12 and 24. Okay. Factors of 24 are 1, 2, 3, 4, 6, 8, 12 and 24. These are the factors of 24 here. Dear students, remember one important point here. Okay, the number 1 is neither prime nor composite. It is not a prime number because it does not have exactly 2 factors, and it is not composite because it does not have more than 2 factors. So dear student, remember this point here. The number 1 is neither prime and nor composite. Now students, here we will discuss one important method to find composite and prime numbers. Okay, prime and composite number. So this method name is seal of Eratosthenes. A Greek mathematician, Eratosthenes, devised a method to find prime numbers and composite number between 1 and 100. What is the basic method here? Here first we write 1 to 100 numbers, right? And here we cross out 1 because it is not a prime number, and after that we circle out 2 here and cross out the multiples of 2. We apply the same rule with other number also. Method is also given in your math book. Okay, so this method is also given in your math book, page number 55. Okay, so here we only learn what the step basically is follow, and we find prime and composite number here. So here first we cross out this 1 because it is not a prime and not a composite number. Now here we circle out 2 here and cross out the multiples of 2. So 2 2s are 4, 2 3s are 6, 2 4s are 8, 2 5s are 10, 2 6s are 12, 2 7s are 14, 2 8s are 16, 9s are 18 and 2 10s are 20. Now here we apply the same rule with 3. Here we circle out 3 and cross out the multiple of 3 here. 3 1s are 3, 3 2s are 6, 3 3s are 9, 3 4s are 12, 3 5s are 15, 3 6s are 18, 3 7s are 21, 3 8s are 24, 3 9s are 27 and 3 10s are 30. Now we apply the same rule with 5. Circle out 5 and cross out the multiple of 5 here. 5 1s are 5, 5 2s are 10, 5 3s are 15, 5 4s are 20, 5 5s are 25, 5 6s are 30, 5 7s are 35, 5 8s are 40, 5 9s are 45, 5 10s are 50. Right? Now we apply the same rule with 7 here. Circle out 7 and cross out the multiple of 7 here. 7 is a 7, 7 is a 14, 7 is a 21, 7 4 is a 28, 7 5 is a 35, 7 6 is a 42, 7 7 is a 49, 7 8 is a 56, 7 9 is a 63, and 7 10 is a 70. So numbers in a circle are known as prime numbers. Yes, numbers in circle are known as prime numbers. So here we write numbers in circle known as prime numbers. Right? And numbers which we cross out here are known as composite number here. So these numbers which we circle out here, these numbers are known as prime numbers here, and which we cross out here, these numbers are known as composite number. Here we will discuss about two types of prime number here, twin primes number and co-primes number. Here we discuss about twin primes and co-primes number here. Twin primes. Twin primes are the prime numbers that differ by 2. It means the difference of these two primes number is 2 here, like 3 and 5. Now 5 minus 3, 2. Then 5 and 7, 7 minus 5, 2. So here these type of prime numbers are known as twin primes which having difference 2. Right, now co-primes. Two natural numbers are said to be co-primes if they have only one as a common factor here. For example, 2 and 3. Now, if we take a factor of 2 and 3 here, like factor of 2, 1 and 2 here, and factor of 3, 1 and 3. Now, what is the common factor here? 1 only. So, here we say that these type of natural numbers are known as co-prime numbers here, which have only 1 as a common factor. Right, same as with 5 and 7 here. 5 ones are 5, 1 and 5. Factor of 5 is 1 and 5, and factor of 7, 1 and 7. Now here we take 1 as a common factor here, so here we say that these two numbers 5 and 7 are also co-prime number here. Prime factorization. Any composite number can be written as a product of prime numbers, an expression written as a product of its prime factors is called the prime factorization of that number. Now here we find the prime factorization of 24 here. Now here first we use method 1, factor tree method here, right? Factor tree. So now here we write 24 here. Now we write factors of 24. Okay, so here we write 12 to the 24. Then find factor of 12 here. 2 6 are 12. Right? Then factor of 6 here. 2 3 are 6. Now here we write the prime factorization of 24 here. Prime factorization of 24. 2 multiply by 2, multiply by 2 and multiply by 3, right? 2 multiply by 2, multiply by 2, multiply by 3. Now here we again, if we multiply these all 3 numbers or 4 numbers here, so you will get 24. 2 to the 4 to the 8 and 8 is a 24, right? Method number 2, continuous division method. Continuous division method. Okay, so here we find the prime factorization of 24 here. So here first we divide this number by 2 because 24 is divisible by 2 here. 2 1s are 2 and 2 2s are 4. Now again by 2, 2 6s are 12, again by 2, 2 3s are 6. So remember one point here, student. Here first we check first smaller number, then we increase the number one by one here. First 2, then if the number is not divisible by 2, then here we check by 3, then 4, then 5 and so on. Now 2 3s are 6 and 3 1s are 3 here. Now the prime factorization of 24 is equal to 2 multiplied by 2 multiplied by 2 multiplied by 3. Now here we get the same prime factorization when we use first method, factor tree method here, and then we continue to use here. Now here we solve the students this question. Complete the factor tree, then write prime factorization. Right. So here 30 and here 3 is given here. So how many times 30 divisible by 3? 10 times. So here we write 10 here. And write 3 as it is here. Then we find the factors of 10 here. And 2 5s are 10. So here we write 2 and 5 here. Now here we get prime factors of 30 is equal to 3 multiplied by 2 multiplied by 5. 3 2s are 6 and 6 5s are 30. Now here, the next question. Here we find what numbers come in this circle. So 205, here we find the factor of 205 here. So here how many times, because this number is already given here 5. So here we divide this number 205 and here we find the next factor of this 205 here. Now 5 divide this 205 how many times? 5 4s are 20 and 5 1s are 5. 5 4s are 20 and 5 1s are 5. Right? So here we get factors of 205 is equal to 5 multiplied by 41. Now the highest common factor HCF. The highest common factor HCF of 2 or more numbers is the greatest of the common factors. It is the greatest number which divide the given number exactly. And here we use 3 methods to find HCF of a number. Right? By listing factors, by using prime factorization method, and by division method. So now here first we will discuss here first method here, method number 1, by listing factors. And here we take one example here, find HCF of 12 and 18 here. So first we find the factors of 12 and write all the factors of 12 here, and same as with 18. So now first we write all the factors of given numbers here. So write all factors of 12 and 18. Then here, so we write factors of 12 are 1, 2, 3, 4, 6 and 12. Right. Now find the factor of 18. So start with 1, then multiply by 18, we will get 18 here. Now 2, 9 is 18, then 3, 3 6 is 18, then 18, we will come to the table of 4, not 5, but here 6. So we will not repeat these factors again and again here. 6 3 is 18, right? So we will write the factors of 18 here. 1 2 3 6 9 18. 1 2 3 6 9 18. So here first we find the common factors of these both number here, and 1 is there, 1 is there, so here we write common factors are 1, 2, 3 and 6, right? 2, 3 and 6. So here we find the greater number out of these all common factor here. So here 6 is the greatest number here. So here we say that SCF equal to 6, right? So SCF of 12 and 18 is equal to 6. So what we do here, first we find the prime factors of 12 here, and after that we find the factors of 18. Okay, prime factors of 18 here. So first we find the prime factors of 12 here. So here we divide this 12 by 2. 2 6 are 12, 2 3 are 6, and 3 1s are 3. So factors of 12, prime factors of 12 equal to 2 multiplied by 2 multiplied by 3. Now here we find the prime factors of 18 here. And we start with 2, 2 9s are 18, then 9, divide this 9 by 3, because 9 is not divisible by 2. So here we divide this 9 by 3, 3 3s are 9 and 3 1s are 3, right? So here we write the prime factors of 18 here, 2 multiplied by 3 multiplied by 3. Now students, here what we do here we find common factors of 12 and 18. So here we get 2 is a common factor and 3 also. Now here we write these two common factors here, 2 multiplied by 3. So here we say that SCF of given number 12 and 18 is equal to 6. 2 3s are 6, right? So basically what we do here we find the prime factorization of 12 and 18 here. Now we take common factor of 12 and 18, and here we get common factors 2 and 3 here, and after that we multiply these two common factors here, 2 3s are 6. So here we say that 6 is the SCF of given number 12 and 18. Now students, here we use another method number 3, by division method. So here we find SCF of given number by using division method. Find SCF of 12 and 18. So here we divide this 12 and 18. First divide by 2, 2 6 are 12 and 2 9s are 18. Now divide by 3, 3 2s are 6 and 3 3s are 9. Here now we stop dividing these numbers here, because 2 and 3 not having any other common factor here, so there is only one common factor out of these two. So here we stop dividing by this number here. So here we write SCF of 12 and 18 is equal to 2 multiplied by 3, 6, 2 3 is 6. Okay, 2 multiplied by 3, then we get 6 here. So dear student, by using all three methods we find the SCF of the given number here. And there is also another division method which we use to find SCF of large numbers. Right? What we do here? So here we take larger number as a dividend and smaller number as a divisor. Right? So here is 12 and 18 here. So here we take divisor equal to 12 and dividend equal to 18. So now here we divide 18 by 12. How many times 12 divide this 18? One time. So here we get 12 here. Now 8 minus 2, 6. 1 minus 1, 0. Now here remember one thing here, and notice one thing here. Here we take this divisor 12 as a dividend here, right? Here we take this 12 as a dividend here, and here we take this remainder as a divisor. Now again, here we take this divisor as a dividend here, and this remainder as a divisor. Now how many times this 6 divide this 12? 6 to the 12. Right, so here we get now 0. So dear students, the last divisor, right? The last divisor is the SCF of the given numbers. So here we write SCF of 12 and 18 is equal to 6. Right? So here we use these all methods to find SCF of numbers. Find the SCF of numbers.